So this is the last note lesson of this chapter. We have looked at the unit circle and measuring things in radian. This whole chapter, the theme has been radian. Our first chapter of trig was all triangles, and when we did triangles, it was all in degrees. In this chapter, we've moved to radians, and the radians show up in circles, and they also show up in the waves. So we're going to see real-life examples of both circular things and wave things that are measured in radian. So when you think about this wave shape we've been looking at over the last couple weeks, can you think of any places where you might have seen that before?
I'm sure I saw it somewhere in science.
Okay. All right. So it could be something in science. All right. Any other ideas? Music? What do you mean? Okay. So did you take music tech? Yeah. And where did you see this in music tech? Okay. Okay, it's a sound wave in music. Okay, different notes have different frequencies. How about at a hospital?
Oh yeah, that machine.
Okay, an EKG machine. Okay, so that's maybe under science. So an EKG machine, which can measure your heart. It also could be a lung monitor. Because what would that look like if you were monitoring your lungs?
Wait, what?
If you were dead. Okay, but what would this be measuring if you were doing your lungs? What could that mean?
Your vital capacity.
Okay, it could be breathe in.
Good job.
Fill the lungs, breathe out. Exhale, breathe in, breathe out. Okay, so on Earth. Okay, sure. It could be an earthquake.
Natural world.
For sure. Okay, microwaves, radio waves, X-rays, X-ray vision. Okay, all of those are that wave. Okay, even though you're not seeing it, you don't see the radio waves, but the radio waves are being sent out at different periods. And the period is what you tune your radio station to. It will pick up whatever's being sent out on that frequency, that period. Okay? It also is tide. Okay, a tide chart. Because what does the tide do several times a day? It rises, it falls. It rises, it falls. If you're out at a pier, okay, and you can see where the high water was and where the low, and the high and the low. The moon. Okay, the moon will get full, and then it'll go to half, and then it'll go to nothing, and then it'll go back to half, and then it'll go to full, and then back to half, and it just keeps the phases of the moon. What else? Weather. Okay, temperatures. Temperatures rise, they fall. They rise, they fall throughout the season. We have the warm season, we have the cold season, we have the warm season, we have the cold season. All right, so this model of a wave is lots and lots of different places. And so you're going to see that in your homework tonight in a couple different ways. So I'm going to start with temperature as our kickoff question, which was like the extra credit you had on your most recent quiz. Okay. Over 12 months, one city has a high equal to 72 and a low equal to 20. Write your own equation that would make this. So you don't need a graph paper to do this, but I would encourage you to think about one cycle. So what do we know about this one cycle? Well, we know that it takes 12 months. So that means you can put an x-axis on here yourself. That would start at 0 and end at 12. Okay, I could tell that from the problem. That's time. And remember, time is always on the x-axis. So this is 0 and 12. What do we call that? What's the vocabulary word that measures from 0 to 12? We've done it for 2 weeks now. No, the amplitude measures this way. Okay, this is called the period. All right, the period equals 12 right now. Okay, so we can tell that from the word problem. Okay, now we've got the high and the low. We've got 72 here, and we have 20. That is not the amplitude. Okay, but it's we should be able to figure out our amplitude from there. Okay. Well, what's the gap between 20 and 72? That's our range. Our range is 20 to 72. That's not the same as the amplitude, but they're connected. So our range right now is 20 to 72. What's that, what's the space between 20 and 72? 52. Okay, there's a gap of 52 between there and there. So if there's a 52 gap, a 52 degree gap between the high and the low, how much of that is above the x-axis and how much of that is below the x-axis if it has to be equally spaced? 26, exactly. Okay, so you can figure out the amplitude, and you know that the amplitude now, let's see, would be 26 that way and negative 26 down. So now you can write your own equation, because the equation is going to be y equals a for amplitude, sine, b for period, x, and then a d for the shift. So you should be able to plug in all the holes and write your own equation to work backwards. So we just figured out, using a little bit of logic but a little bit of math, that our amplitude is 26. Sine, now I have to figure out the b. We've talked about that before. We know that there's a formula that says period equals 2 pi over b. Remember that formula we learned? Well, then what would b be equal to? We talked about that already as well. 2 pi divided by the period, right? So what do we know right now? Do we know b or do we know the period? We know the period. We know the period is 12. And so b would be 2 pi divided by 12, which reduces to pi over 6. So I can come back to my equation, and I'm going to have pi over 6 for my b. And now I need d. D is the shift. D is the shift which took this thing normally from being 26 and negative 26 and bumped it up to the position of 72 and 20. So if the amplitude is 26, but I'm supposed to get all the way to the number 72, how much do I have to add? How much would I have bumped this whole thing up? Do a little, what's the gap between the amplitude and the high value? How much? Yeah, you can, that's why I told you to have your calculators out. Okay, 46. Okay, that's the difference between 26 and 72. So you just wrote your own model. So you'll be given data, and you create the model for the temperature. Okay? Thinking again about this, 0 to 12, what months does that represent? Okay, 0 is January, Is it? Is 0 January? What's January? January is 1. So what's 0? December. And what's 12? Also December. Okay? And what's the middle? June, which is 6. Okay? All right. Okay, let's try another one.
Can you explain again, Joe, about this?
Sure. 26 plus 46 equals 72. So 46 is 72 minus 26, subtraction. All right, let's try another one. A Ferris wheel has diameter 50 feet. It goes around every 40 seconds. Okay. And it is raised 30 feet off the ground. So when you get into a Ferris wheel, what direction do you go? I mean, you're going up or down? I mean, I know you're going in a circle, but you're going up, right? Doesn't matter if you're going counterclockwise, but you're going up until you get to the top. And then after you get to the top, what do? You come back down, and then you do it again. Okay, so if you were keeping track of your time, you'd be going up and then down and then up and then down and then up and then down. And so if you were keeping track of your time, you'd be going up around the Ferris wheel, and then I'm not going to have you draw it as you're going back around, but because we're measuring time, and then down and then up and then down. This is measuring your time. All right, so what is the time in this situation? How long does it take to do that, to do it once? 40 seconds. So then you're going to measure one cycle is going to be 0 and 40. What is that called? The period. Then can you figure out the B from that period? Hopefully, you for surely can figure out. So we know the period is 40. And so B is 2 pi divided by 40, which is pi over 20. We also know the Ferris wheel has diameter 50 feet. Okay, it has diameter 50 feet. So how high do you get? The diameter is very good. And so we get 25 and 25 because the diameter is 50, but the radius is only 25. Okay, so what do we call that? The amplitude. All right, so we're going to write our equation. Y equals A sine BX plus B. Y equals 25 sine, my B turned out to be pi over 20 x, and then we know it's been raised 30 feet off the ground, so plus 30. Okay? So how high are you really getting? You're really getting 55 because that's 30 higher. It's been raised off the ground.
Isn't this the basic question?
It's similar. Mm-hmm.
Oh wait, how'd you get the 55?
I added 30
What is that?
Oh,
because it said I did 25 plus 30.
makes sense.
Okay. Okay. So now you might be asked a follow-up question. When will you be 40 feet high? And this is where you'll need your graphing calculator. Okay, when will you be 40 feet high? All right, so would you please grab out your graphing calculator? And we need to set our window according to the domain and the range. Okay, yeah. All right, so first thing, please make sure that your calculator is in radian mode. All right, please make sure your calculator is in radian mode. So hit mode and double check that you're in radian. All right, second thing is you can't graph anything until you make your window appropriate. Your window has to match the period and the range. So go to your window. For this problem, the period is 0 to 40. So you need to make sure that you match 0 to 40. And we talked last semester about making a good X scale by taking 0 to 40 and dividing it by what number? I'll remind you, that was the number 10. So take 0 to 40, divide it by 10, what do you get? 4. Okay, so that's a good scale. Your min and max should match your range. So for this problem, our range is 5 to 55. So make sure that your window matches your range of 5 to 55. Also, a good idea to take that and divide it by 10, and so that would be 5. Okay, so now once you have your period and your range set for your window, now you're ready to put the equation in. So would you put the equation we just created, which was 25 sine pi 20th x. Now when you type this into your calculator needs you to put pi and x above the 20. So the 20 should come after the pi and the x. And then plus 30. And if you did everything right, we should see one perfect cycle on our graph. So hit graph, and we should see one perfect cycle. If you don't see a perfect cycle, it's because you made a mistake typing in the equation or you made a mistake in your window. Okay, so that should look just like we expect. Okay, anybody having